In 1954, the United States witnessed the first kidney transplantation, which was also the first successful organ transplantation across human history. Later, liver transplant, lung transplant, and heart transplant succeeded in a row. Today, more than 10,000 people benefit from organ transplantation each year in China alone. Countless lives have been saved by this technology. But the ultimate challenge in the field of transplantation is hand transplant surgery. When hand transplant surgery is typed into a search bar, a variety of articles and videos pop up. Some of them tell that the first hand transplant surgery has been done. Is that true? In 2015, Sergio Canaro, an Italian neuroscientist, announced that the world's first human head transplant surgery would be completed 2 years later. It was reported by news forums, magazines, and TED Talks for a while. Then there was no follow-up. In 2017, still Canaro announced that he had completed a hand transplant surgery, cooperating with a Chinese medical team. However, this was only an attempt on cadavers. Head transplantation on a living body has not yet been achieved. How difficult is it? We have 2 volunteers to simulate the following surgical procedure. Patient A will provide head in this surgery. Patient B will donate his body. The surgery can be roughly divided into 3 steps. Cut off the hands of A and B. The hand of A is attached to the body of B. To avoid immunological rejection of surgery, anti-rejection therapy is performed. It's an ultra-complicated surgery that requires 150 people and takes 36 hours. We have to cut the head out from the third section of the spine, where there are countless blood vessels as well as muscles, nerves, trachea, esophagus, and other organs that need to be gradually separated, severed, and reconnected. The first difficulty of hand transplant surgery is to ensure that A's head is alive after cut off. Human cells need oxygen to survive, and organs that leave the body without blood for oxygen will quickly fail and die. The liver, for example, loses its basic function after 30 minutes away from the body. Therefore, low temperature is required to reduce the metabolic rate. We can take cryopreservation and cool A's hand to 12 to 15 degrees Celsius, at which point the metabolic rate will drop to 10% of normal. However, it can only last for 1 hour at most, and it's uncertain whether any hidden damage such as short-term or permanent memory loss. There is another approach, cross-anastomose. In 2014, Chinese professor Ren Xiaoping used this method to transplant the hands of 18 mice in an experiment. Eventually, 13 mice survived for 3 hours only. The advantage of this method is that it restores the blood supply of the brain in the shortest time. However, during surgery, the brain will inevitably experience a few minutes of blood circulation stoppage. Another challenge lies ahead: the severance and fusion of the spinal cord. The spinal cord is an important part of the body's central nervous system. The butterfly-shaped middle part called gray matter. The outer layer is the white matter. Further out are the spinal pure matter, cerebral spinal fluid, spinal arachnoid matter. Cutting the spinal cord must be done with very sharp scalpel to avoid causing scars and cysts. Moreover, the axons of nerve cells in the spinal cord will begin to disintegrate after 10 to 20 minutes of transection. A method called spinal cord fusion is adopted here, in which a PEG-based solvent is used to fill in between the 2 cross-sections of the spinal cord. Polyethylene glycol has a wide range of uses in the biomedical field. The main function here is to protect cells and promote cell growth and fusion. That's all we can do. The PEG provides a foundation, and the neural bridge is being made by the self-repair of the nerve cells. Why can't we sew up the nerves in the spinal cord like blood vessels? In less than 1 centimeter spinal cord, there are 20 million specific nerve fibers, which transfer information at more than 180 kilometers per hour. We have no idea where each of them leads to. The existing equipment and technology simply cannot operate on such tiny nerves. PEG-assisted self-repair of the spinal cord cannot fully restore all nerves. The current best assumption is that the spinal cord can be repaired to 10 to 15% of its original, which means it's possible to restore sensation in the extremities and simple motor abilities. Moreover, nerves may mismatch when they repair themselves. Non-particularly extreme mismatches between nerves can be corrected by the upstream central nerve. As for extreme neural mismatches, limbs coordinates, paralysis, and even death are possible results. According to Ren Xiaoping's paper published in 2019, dogs with severed spinal cords can surprisingly run and jump 1 year after surgery. Professor Ren has also gradually conducted human clinical trials. He said, "We have successfully connected and reconstructed the spinal cord defect through surgery and neurotransplantation. Assuming that the problem of spinal fusion is overcome, there remains a fatal challenge: immunological rejection. Like pollen hypersensitivity, when we transplant another person's organ, the immune system mistakenly thinks we are being invaded and goes on an attack against the transplanted organ. Even with a single organ transplant, a patient can die from autoimmune rejection. In a head transplant, A's brain has a lymph nodes involved in the immune system, while B's body has an equally complex immune system. The intensity of this rejection can grow exponentially. If they attack each other, no matter who wins, the patient will die. Therefore, patient A needs to take a lot of anti-rejection drugs such as cyclosporin, sirolimus, tacrolimus to weaken his immune system. However, the side effects are obvious. A will lose the protection of immune system, and long-term medication may lead to liver and kidney failure or other diseases. These are three main challenges about hand transplant surgery. By this point, maybe you have more confusions. The Mars landing plan is indeed difficult. However, how far away is Mars can be measured, but how far away is the success of hand transplant surgery? We have no answer. I wouldn't be surprised if living head transplant succeed tomorrow. Now, would I be surprised that maybe a century later we have grown potatoes on Mars but still haven't achieved living hand transplant? Even if all above medical challenges overcome, there are public opinion, moral, and ethical issues. Who is that person, A or B? He married C and has a child, D. Who is D's father? Legally, D is A's child, and genetically, he's also B's child. These so striking questions may only be answered when they really happen.